Welcome to classes on ray optics of physics, H.Sc. second year, and today's topic is PRISM and optical instrument. You please minutely follow the classes with cool mind so that you can learn a lot of things which will helpful for you to answer a lot of questions in the entrance exam as well as in board exam. So first of all, in PRISM, though I have already done a lot of things about PRISM, so let me first explain the term dispersion. What actually a dispersion is? It is the splitting of white light into its constituent colors when it is made to pass through prism. Very simple. It is nothing but splitting of the constituent colors of white light when it is made to pass through prism. That is, when white light is made to pass through prism, then it splits into several constituent colors after passing through the prism, and this phenomenon is called dispersion. Now, main fact of dispersion is that why their dispersion occurs. Why their dispersion occurs? Dispersion depends particularly on angle A and lambda of light fall upon it and material of prism. So, angle of prism and lambda of the light, wavelength of the lights and material of the prism, these are the factors upon which dispersion depends. Now, how does it depend? Number one, it depends on angle of the prism. Number two, it depends on lambda. Now, how the lambda, the dispersion is dependent upon the lambda of the light incident upon the prism means if the lambda is long for red letter right, then velocity in prism of red light is more. Deviation is less. So, more lambda, more velocity, less frequency, less mu. So the main fact is that when the red light is made to pass through the prism, that we know that the red light has a more wavelength and it has more velocity in the prism than other light, and since its velocity is more, its deviation is less after refraction through the prism. More velocity, less deviation means there is a deviation in dispersion, and due to this deviation and dispersion cause this difference in angle, and due to difference in angle there is dispersion, and that creates a band of light which is called spectra. So we see lambda more, wavelength more means velocity more, means frequency less, means mu is less because mu is related to lambda. if the wavelength is more, by Cauchy's relation, Cauchy's equation, we see mu means refractive index of a medium is inversely proportional to square of its wavelength. So more the wavelength, less is the refractive index. And another is material. Another factor is material of the prism. Am I right? The dispersion also depends upon the material of the prism with which it is made of. So the main factor, more the velocity, lambda is more, velocity is more, deviation is less, or more the velocity, lambda is more, frequency is less because mu is inversely proportional to 1 by lambda. Am I right? So these are the some factors upon which dispersion of light in prism depends. So when light, one of the important things you keep it in your mind, when wet light is made to pass through this one, so we are assuming only three lights. One is red, other is yellow, other is violet. Since lambda of red light is more, is speed of velocity of light inside the prism is more, deviation is less, then the less deviation is y, and highest deviation is the violet light. So we have seen, due to this, if you just extend this one, deviation of R light, deviation of Y light, deviation of violet light, and this red light is called mean ray. MEN, mean ray is yellow light. You keep it in your mind. So we have seen the dispersion, phenomenon of dispersion and its dependence upon factors. I have already mentioned in the earlier class, the minimum deviation delta m is equal to mu minus 1 into a, where a is less than equal to 10. Maximum deviation I1 or I2 is equal to Now, what is angular dispersion? Angular dispersion, it is the difference of deviation of two extreme lights, red and violet. Extremely lights, red and violet, because it is least deviated and it is highly deviated. At the top R and at the bottom there is violet light. So this two deviation, difference of deviation of these two extreme light is actually called angular dispersion. So angular dispersion is dV minus dr is equal to sec theta. So angular dispersion is nothing but the difference of angle of deviation of two extreme light. One is red, other is violet. So del V minus del R is equal to theta. If you assume it theta, so angular dispersion is the difference of the dispersion deviation of the extreme two light, violet and radiation, red light. So what's happened? We have already seen that delta is equal to minus 1 into A. So here for delta V, if you assume here B, so delta B is equal to delta that is angular deviation. If you write that it is the difference of the deviations of two extreme lights, one is violet and other is red. So dB minus dr is equal to theta, and dB is equal to mu minus 1 into A. means for violet light, so mu v minus 1 into A, and mu r for red light minus 1 into A. If you take a simple calculation, we will get mu v minus mu r A is equal to theta. So this is the formula of angular dispersion. Dispersive power, it is nothing but the ratio of difference of deviations of two extreme light to the deviation of mean ray. That is dB minus dr means it is the difference of the deviation of two extreme lights. If you divide it by the deviation of the mean light, then this two ratio is called dispersive power designated by omega. So omega is equal to dB minus dr by dy. That is, we have already calculated dB minus dr is the angular dispersion. So this angular dispersion already done, we have mu v minus mu r into A, and d of y is equal to mu minus 1. So mu y minus 1 into A, so A cancel out. So we will get mu v minus mu r equal to mu y minus mu 1 is equal to dispersive power omega. Am I right? So here very important term, very often you will be confused with the term deviation without dispersion, and another term you will get dispersion without deviation. Here what does it means? Here there is only deviation without dispersion. Finally, when light fall upon one prism, and it is done only in achromatic combination of prism. I will explain the term achromatic combination. So when two prisms are kept side by side with certain conditions, when they are placed side by side attached, and if you make to pass some light upon the first prism, and it will go out of the second prism, and it may give dispersion, it may not give dispersion. But here the condition is there will be deviation. There is a condition. What is the condition? Condition for deviation without dispersion. If you want to make dispersion without any deviation, there will be deviation and there will not be any dispersion, means there will not be any splitting of light, red, yellow, blue. There should not be any splitting of light. If you place white light, we have seen when white light is made to pass through the prism, after deviation through the prism, after passing through the prism is splits up into its constituent color. But there are some condition upon which when white light is made to pass through the prism combination, then without splitting out, without any dispersion, it will just deviate. Now what is this condition? It will just deviate without dispersion. It will not splits up into different color. Now here I have written inside the bracket achromatic combination. Achromatic combination means two prisms are placed side by side in such a way that chromatic means color. That is angular dispersion made by one prism is cancelled out by the angular dispersion by other. Angular dispersion made by this prism is cancelled out by this prism. Means finally there should not be any angular dispersion in the final stage. If there is no difference in angle of dispersion, then there will not be any dispersion. The line will pass as line, means it will refract. No dispersion, means that condition is called achromatic condition. So in this case, achromatic condition, we place a crown prism, prism with crown glass and flint. Two prisms are placed in side by side in such a way that angular prisms are in opposite directions. If we make the combination in this way, where the angular dispersion of one prism is cancelled out by the another, where the mu of these two prisms are different, then this combination is achromatic combination, and other is remove a chromatic combination. Means here the light will splits up into different color, but deviation of mean light will be parallel to the incident light. In second case, the chromatic combination, that light of different color, chroma means color, different color will splits, there will be dispersion, but mean deviation of mean light, yellow light, will remain parallel to this. Means there will not be any deviation, parallel to the light of incident ray, which was incident. If it is incident this way, this will be in the same parallel to this one. Finally there will be no deviation, there will be dispersion. When there is a dispersion without deviation, this is chromatic combination. Means light in different color will come out, but the deviation of mean light will be zero in parallel to the incident ray. And achromatic combination means here the angular dispersion made by the one prism is cancelled out by the other when the prisms are combined in such a way with two different glass, one is crown, other is flint, and angles are in opposite direction. Now we will know what our condition is. Without dispersion means there should not be deviation of angular dispersion should not be there. If there is angular dispersion, then there will be dispersion. If there is no angular dispersion, so where there should be achromatic combination, angular dispersion of one prism is cancelled out by the other. So how this combination of two prisms will be, that the prism should be placed in such a way that the angular dispersion of one prism, say crown prism, prism made of crown glass, is cancelled out by the other prism made of flint glass, and this is called achromatic combination. When we will do achromatic combination, now what will happen? Let us see. Now you see, when white light is made to pass through the first prism, it is made of crown glass and it is flint glass, and in this achromatic combination, then white lights, I have assumed two light, one is red and other is violet light. So deviation of red light is like this, deviation of violet light in first prism is like this, and both the one will come in the same point, it will come out this one. So what does it means? The light fall upon the prism was W. After passing through combination of the prism, it is again white. Means there is no dispersion, no, there is no splitting of the color. Splitting of the color means there is no dispersion. Now what is the condition? In this condition, how will you derive the relation? And it is known to us for the when it is made to pass through the prism, first prism made of the crown glass. So change of deviations dB minus dr is equal to mu b minus mu r into a, we have done already earlier. Now when same light is passed through the second prism, means with flint glass, then the deviation is different, and that difference is dB dash and this angle is adjust. So we have got difference of angular dispersion in first prism and second prism, where there is change in refractive index, we have shown it by lambda, bar, a dash. Am I right? So first dB minus dr is equal to mu b minus mu r into a, and second dB dash in the second prism, and b r dash equal to b r dash minus mu a is equal to this. Now what is for null dispersion? These two, when we will add up, final dispersion is 0, means this is the condition. So we will get a by a dash equal to mu b minus this. From general mathematics, nothing to explain. Delta is equal to delta 1 plus delta 2, means the total deviation is equal to deviation of the mean light in the first prism plus deviation of mean light in the second prism, means mean light means yellow light. So total deviation is equal to deviation of the mean light in first prism and deviation of mean light in the second prism. So what we get here is mu minus 1 a plus, it is for mean light yellow light for first prism, yellow light for second prism, changed. So in the derivation we have seen that this is equal to this 2 is equal to the deviation of the mean light means yellow light in the first prism and second prism equal to d1 plus d2 is this. If you take the common, you take this common term here, this will be 1 plus this minus this, and we have taken this one, so a is below and this like this. Am I right? So these two cancel out, you will get this one. This part is common to you, you can understand yourself. Now if you arrange this one, so a dash minus a, I have already proved, I have already shown is mu b minus mu r in the I have fished out mu b minus mu r equal to mu b dash minus mu r dash. So yeah, I have placed this one and there is a minus sign, I have taken this one. You can assume minus or may not assume minus term. So if you take these two terms side by side, these two terms side by side, so mu b minus mu r, mu minus 1 is equal to w1 of the first, it is first prism dispersive power. So mu b minus mu r divided by mu y minus 1 is equal to dispersive power of the first prism is equal to w1, and that should be, this should be numerator and this should be denominator. Mu v dash minus mu r dash divided by mu y dash minus 1 should be w dash, but since it is reversed, I have written is 1 by w2. So we have got the deviation for deviation with the dispersion is mu y minus 1 into a into 1 by w1 into w2. That is this is the condition for dispersion, deviation without dispersion. Means here white light will finally come out as white light without any dispersion, but refraction occurs. So white will remain white, means there is no dispersion, but it has deviated as white light as white light, means it is reflected through the second prism. So it is quite reverse of the earlier one. Here the condition for dispersion without deviation, there will be dispersion, but there will be dispersion, but there will not be any deviation. Without deviation there will be dispersion, means chromatic combination, means light of different white light when fall upon the that type of the combination of the prism, it will emerge out with dispersion, but without deviation. Without deviation means the mean light deviation will remain parallel to the incident light. So incident light is white light and mean light is that white yellow, and mean light deviation is remain parallel to this one, means it is not deviated, deviation is zero, but other color will disperse. So it is dispersion without deviation. Here in earlier it is crown glass, it is flint glass, and A and A dash of the two prisms are placed in this opposite direction. So here dispersion without deviation, in which the deviation generated by the one prism for the mean light is cancelled out by the other prism for the same light. Deviation made by the yellow light is cancelled out by the other prism for the deviation of the mean light generated by the first prism, is called dispersion without deviation, means other light will disperse, but its deviation of the mean light, yellow light, will be parallel to the incident ray. Deviation of mean light is parallel to incident ray. This is called dispersion without deviation. For this condition, delta is equal to 0, that is deviation, total deviation is equal to 0, means that deviation is d1 plus d2, deviation of mean light for one prism is d1 and deviation of the same light for other prism is d2. So d1 plus d2 is equal to 0, means what is d? At the very beginning we have already shown mu minus 1 into a plus mu minus 1 into a is equal to 0. So for the first prism of mean light deviation, means yellow light deviation, that is will be yellow, and this is for E, and this is for second prism, and the refractive index is different, mu dash, and the angle is also different. So we have got mu minus 1 a plus mu minus 1 dash a plus a dash equal to 0. That means mu minus 1 a is equal to minus mu minus 1 a dash. That is a dash by a is equal to this. Very simple, nothing to explain. Angular dispersion, say it is final theta, theta 2 minus theta. It is known to you, for second prism angular dispersion is equal to this, for first prism angular dispersion is equal to this. So difference of two dispersion is equal to this minus this. Now let us take common. So if you introduce this term mu minus 1 a into a, and that term will be the below of this term to balance it, and a I have taken out, that a should be below this. So these two cancel out, we will get this one. And again from this, if you take mu minus 1 a, means mu minus y, mu y minus 1 will be below, and a we have already taken, so mu b minus mu r by mu y minus this. So from this, so just to see, mu minus mu y minus 1 a is same of this one, mu b dash, these two are same, a by a dash equal to mu minus 1, mu y dash minus 1. Earlier we have written, I am effacing out, just I have put the value of these two, and these two will remain same, mu b minus mu r divided by mu y minus 1. So for this condition where dispersion without deviation, here we get mu minus 1 into a and mu dash minus mu, because if you take out this one, so by cancelling out we get mu v dash minus mu r dash by mu y dash minus y equal to omega dash, means dispersive power of the second prism, and mu b minus mu r mu y minus 1 is equal to the dispersive power of the first prism. So mu minus 1 into a equal to w dash minus w or mu dash minus omega dash minus omega. It is the resulting condition for dispersion without deviation. So let me come to the second point, and it's very important and interesting. It is not tough. That is optical instruments. These are the instruments with the help of which we can use a lot of things to view, or a lot of things, smaller objects and far objects to view. These are the optical instruments. And first of all, we have taken simple microscope. Simple microscope, what is its application? It is used to view all smaller objects or small objects. And how it is consist? It is consist of single convex lens, and it is called magnifying glass, or also it is called a reading glass. And its magnification is very important. For example, point of view, magnification 1 plus d by f maximum if image is at least distance of distinct vision, and magnification uh, at infinity is d by f minimum if image is at infinity. So two magnification. One magnification when image is least distant or distribution MD is equal to 1 by d by f. D is the least distant distribution and f is the focal length of the convex lens, and magnification at infinity is equal to d by f minimum image is at infinity. Now what is simple microscope? How will draw it? The condition is that in the convex lens, if the object is placed in between optical center and focus, that is in lesser focal length, if the object is placed in between optical center and focus, then image is formed on the same side of the convex lens and it is erect, partial, magnified. And this is very simple and nothing to explain. This is nothing but the main principle as to how the simple microscope works. So this is all about compound microscope. We have here, there are two lenses, two converging lenses. One is this and other is this. There is two converging lens. One is objective and other is eye lens or eyepiece. Object is at O and eyepiece at this position. So when we place an object AB in front of a convex lens of smaller focal length and other is convex lens of higher, bigger, longer focal length. So smaller focal lengths in front of this we have placed an object AB and image is formed at B dash A dash, and that image acts as an object in place of eyepiece from where we'll view this object, final objects. So we have seen that this image which is formed from the first objective, the image formed is B dash A dash is becomes object of the eyepiece, and this object gives rise to the final image at Q, and this is inverted. So what we get, that the first image formed by objective A dash B dash is real and inverted. And final image, that Q at Q is virtual and inverted. It is in between the two lenses. Now that distance is equal to object distance UE, and the first object image formed from the first objective is A dash B dash, and that distance from this to this is equal to V naught. image from the objective is equal to V naught, and now the object in place of eyepiece, in front of eyepiece, is equal to object distance UE, that much, and final image from eyepiece is equal to this to that much is equal to VE is equal to, add two magnification, there will be magnification at image at this distance of distribution and image at infinity. So now Now, the magnification when image is formed at this distance of distribution, magnification is equal to minus B naught by E naught. I have shown you B naught, U naught, sorry, this should be U naught from objective, U naught and B naught, U naught, 1 plus D by F, this distance of distribution F is equal to focal length of this one, and where the LD is equal to length of the tube of the compound microscope will be B naught plus E naught, B naught plus A naught. This is the length of the tube, B naught plus UE, when object is this distance of distribution. Now, when object is at image is at infinity, now B by B naught equal to D by FE, then the distance of the tube, length of the tube LD is equal to V naught plus focal length of the second lens. So this is the magnification MD and magnification at infinity for compound microscope. The terrestrial telescope, it consists of three lenses. One is objective, second is erecting lens, third is eyepiece or eye lens. So when object, it is view the far object, it is used to view far object. So object is at infinity, so the rays from the object falls parallel to the objective, means first convex lens, and it reflected in this way, and after refraction it gives you a dash b dash which is inverted. And now this image is now become sorry, an object of the erecting lens, and that objects gives image by this erecting lens like this. And again this image of the erecting lens will become object of the eyepiece, and that becomes a final image at PQ. So now the distance between this to this is equal to FE, and FO, focal length of the objective, and between this is twice F, because it is a smaller lens, and the image formed, that is object, image of objective, that is object of erecting lens, is at twice F distance of small lens. So this small lens focal length is twice F. Now so this length is twice F, again this length is again twice F. The image formed by this one is at this twice F, and the focal length of the final eyepiece is object distance of this one is UE. Am I right? So FO twice F UE, object of eyepiece, image of erecting lens. So in this way we get the final image PQ, which is virtual. So here one thing is that the two images, intermediate images, are real. One is this, other is this. One is inverted, other is erect. Now the final image produced by the eyepiece is PQ, which is virtual, erect and small, magnified. Now the magnification at this distance of distinct vision is equal to F naught Fe. F naught is equal to this much, and Fe is the focal length of the eyepiece, plus 1 plus Fe by d. D is the least distance of distinct vision, and LD means length of the tube is equal to F naught plus 4F, F naught plus 2F plus 2F, that is equal to 4F plus UE. So this total length is the length of the tube if the image is formed at this distance of distinct vision. If the image is formed at infinity, then it is F naught by Fe, and the length of the tube will be F naught plus 4F plus not UE. It is the focal length of the eyepiece. So FO plus 4F is equal to Fe. So this is the tube length when the image is formed at infinity. That is, in terrestrial telescope, the so this is a very important thing. So you see the real images, one is at B dash and other is B double dash, and the distance of these two real images, one is twice F, other is twice F. Am I right? So distance between length between two real images is 4f. Two real images is twice f and twice f is equal to 4f. So since the length between two real images is 4f, the length of the telescope increased by 4f. Very often in the entrance exam it is asked the length of the telescope, terrestrial telescope increased by dash. Answer 4f, because the distance between two real images is equal to twice f plus twice f equal to 4f. So the length of the terrestrial telescope is increased by 4f. This is all about the today's class, dispersion by prism and some of points of optical instrument. Hope we have followed the class with utmost interest. In my next class, I will appear with new concept in physics wave. So thanks a lot for watching the class, and you please don't forget to subscribe the class.